Okay, lesson 5.4. We're using all these formulas in the box at the top. And so we're going to break up cosine of 75 into two degrees that we know on the unit circle. So 30 and 45 are two special angles that we know the cosine of on the unit circle. So then we're going to use that formula to break it up into the two separate parts. Alright, and then using the unit circle, we'll find the values for each of those. So cosine of 30, we can switch to root 3 over 2. Cosine of 45, we can switch to root 2 over 2. And so on. And from here we just simplify, and then we're good to go. Alright, moving on to the next one. We're going to use a different formula. So the ones in your book that you have for homework, they give you what the whole number, like the pi over 12, what that breaks up into. So it'll already say like pi over 3 minus pi over 4, so you don't have to figure that out on your own. But that's what this one breaks down into. So sine of pi over 3 minus pi over 4, two special angles that we know about. And then again, use that formula up top. Alright, this one just so happens to end up being the exact same as the first one. That was not intentional. They just end up having the same answer. And on to the next one. Alright, this one's a little different. They're giving us the broken up version and asking us to switch it back. So this one is tangent of 40 plus 10, which is the same as tangent of 50. And that's it. So I just had to match it up with, it's the tangent equation with the sum. Alright, the next ones, we have to draw triangles. So they get a little bit more confusing. So when it says that the angle is between 0 and pi over 2, that is going to be in quadrant 1. And then when it is between pi over 2 and pi, that is in quadrant 2. So I'm just writing out the formula for the sum of the angles for sine. And then I'm going to end up drawing triangles. So you might want to write small on this one. Alrighty, I'm starting off with the triangle that is in quadrant 1. And I know that sine of that angle is 4 over 5. So that means the opposite over hypotenuse, because sine is opposite over hypotenuse, is 4 over 5. But I really will need to know the cosine of u. That's the one I'm missing. So to find that, I'm using the Pythagorean theorem to find that missing side, because cosine is adjacent over hypotenuse. That gives me a value of 3 for the adjacent side, and then the cosine is 3 over 5. Right now in quadrant 2, I know that cosine, ooh, I can barely read my screen. Hold on. Alright, so I think 12 and 13, and then if you use the Pythagorean theorem, you end up getting 5. So then the sine opposite over hypotenuse is going to be 5 over 13. And now I'm just going to switch out what I know in that sum formula. So sine of u was given to me as 4 over 5. Cosine v was given to me, negative 12 over 13. And then cosine u I found to be 3 over 5. And sine v I found to be 5 over 13. Right now, just multiply straight across to multiply the fractions, and then they'll end up with the same denominator, so we'll add afterwards. But I need to erase the triangles to have a little bit more room. Alright, and then simplify this fraction, so negative 33 over 65. That's that. Alright, we're going to do another one like that. And this time we have a triangle in quadrant 3 between pi and 3 pi over 2, and then in quadrant 1. So starting with the one in quadrant 3. Now in this quadrant, sine and cosine are negative. So just keep that in mind. Drawing my right triangle, drawing what I know about it. I'll label the sides, and then I don't think I do the Pythagorean theorem in this one. Maybe I did it on a calculator to find the missing side. I did not show my work. Oh no, I did. Alright, so that missing side is 8, if I remember correctly. There we go. Alright, I was wondering what was going on. Alright, and I need to know what the sine of that angle is. So it is going to be negative 8 over 17, because in quadrant 3 again, both sine and cosine are negative. In quadrant 1, they're both positive. This ends up being the same triangle as before, so I already knew the other side was going to be 3, and that cosine was going to be 3 over 5. Alright, filling in this time for cosine of u minus v, so I'm using that difference formula up at the top or in the front of your notes in the box. And that is cosine u cosine v plus sine u sine v. And now I just fill in what I know. So cosine u is negative 15 over 17. Cosine v is 3 over 5. Sine u is negative 8 over 17. And sine v is 4 over 5. Again, just simplify the fractions, combine them, and you're done. I had issues with multiplying. 8 times 4 is negative 32. All right, on to the next one. Now this one is a wee bit more confusing. We have to think back to arctangents and what that means. So the inverse. So when I already know that tangent is 1, what angle would that be? Instead of figuring out the coordinate. So I'm just going to go ahead and fill in for cosine of u plus v using arctangent of 1 as u and cosine of x as v. All right, you can use a calculator for this to figure out the arctangent values, but the book, in the section 5.4, went ahead and drew out these triangles, so you wouldn't have to do these just all like off the top of your head. But for arctangent of 1, it was this triangle. And for arc cosine of x, it was this triangle. Alright, so now I need to find the cosine of that first triangle. And so that's going to be adjacent over hypotenuse. So 1 over root 2. And we'll switch that later. And then the cosine of the second triangle is x over 1 minus the sine of the first triangle is 1 over root 2 again. And then the sine of the second triangle is the square root of 1 minus x squared over 1. I'm going to erase these triangles. Again, they're in the book. Don't worry too much about them. I didn't give you any like that on the homework. Alright, and then multiplying the fractions and combining them. I don't end up rationalizing this because it's not super important. Like I don't multiply the numerator and the denominator by root 2. So I just leave it with root 2 in the denominator, and that is it. Right, number 6, prove the cofunction identity, and then it's given to you. So the one with the subtraction, we are going to write out using the difference formula, and we want it to simplify into sine x. So let's see if that happens. Alright, so the cosine of pi over 2 is 0. So we have 0 times cosine x plus the sine of pi over 2 is 1 times sine x. So I end up with 0 plus sine x, which is just sine x. So I did end up getting the other identity, the other side of it. Alright, this one's just about the same. This time I have a theta instead of an x. And I'm using that difference formula again to simplify this expression. Alright, cosine theta stays. The cosine of 3 pi over 2 is 0. Sine theta stays, and the sine of 3 pi over 2 is negative 1. So now I end up with a negative sine of theta. Alright, now I'm using the tangent formula. So tangent of a sum is tangent theta plus tangent of pi over 1 minus tangent theta times tangent pi. Alright, and then simplifying that, tangent theta plus 0 over 1 minus tangent theta times 0 gives me just a tangent theta over 1, which is the same as tangent of theta. Alright, last one. Find all solutions of this, and I should have put in the interval 0 to 2 pi, so we're not having to do the 2 pi in or anything like that. But I am first using the sum formula for sine. Okay, and then adding to that the difference formula for sine. And setting that equal to the negative 1. Alright, so something nice happens. Cosine x sine of pi over 4 cancels, and then I have 2 of the same thing. So I have 2 sine x cosine of pi over 4 equals negative 1. So cosine of pi over 4 is root 2 over 2. Alright, and now I have 2 times root 2 over 2 is just root 2. And then it still equals negative 1 on the other side. So you divide by root 2 on the other side, and then I rationalize this. So I have sine of x equals negative root 2 over 2. So on the unit circle, I need to find where that is. It's at 5 pi over 4 and 7 pi over 4. And right now I add in the interval 0 to 2 pi.